Hi, fifth grade. We're going to go over Science 8.2. Now, bear with me. I'm going to do the best that I can to try to describe this all for you, and I hope I get it good enough for you to understand. Okay, so after you read through this section, there was a lot of jargon in there about temperatures and this and condensation, that, and humidity and relativity and saturation and all this kind of stuff. So I'm going to break it down as simple as I can for you, okay? And that is one. In the air, there is moisture. Even right now, while we're standing right here, there is moisture in the air, okay? So relative humidity measures the amount of water vapor that the air can hold at any given temperature. Okay, so in some parts of the country, we say, oh my gosh, the humidity is so bad. And sometimes, even this last year, we've had a few of those muggy, sticky days outside on the playground. Then we've said things like, oh, the humidity. That's because there's been more water vapor in the air. Okay, now when we say humidity, what we're really meaning is relative humidity, meaning how much the air can actually hold of water vapor at the given temperature. Okay, so it's like doing three different ways, okay, depending on the temperature outside. So say our normal temperature, right, is, you know, maybe about like 60 degrees Fahrenheit, and then we have 80 degrees Fahrenheit, and then we have 100 degrees Fahrenheit, okay? We're going to go with that just so we can see. Obviously, things are different in like Florida versus California, but we're going to show you here, okay? At 60 degrees temperature, it's colder air, right? Colder. So that means that the water vapor within the air is a lot less. Just like if you had this cylinder right here full of air, okay? Then this part would show 50% of this amount of space has 50% of water vapor in it, okay? But then if you go to a higher temperature air and it's hotter, it can actually hold more water vapor, okay? Which means this higher temperature has more volume, okay? Which means it can hold more water vapor. Then we go to a higher temperature, meaning even higher than, you know, the hotter warm air, okay? We then have a bigger glass of air, we're gonna say, and even though I only did 50% for both of these, this one ends up showing a little bit more, okay? It shows more water vapor, okay? Because the higher the temperature goes, the more water vapor it can hold. The cooler the temperature goes, the less water vapor it can hold, okay? Now, as the temperature goes up, and the water vapor goes up, and it gets to a point where the air can't hold any more water vapor, that's called saturated. And that means it's at 100%, okay? The humidity of the air is at 100%, meaning that those air molecules got all the way to the capacity and can't hold any more air, okay? Or any more water vapor in the air, okay? Then when that happens, we actually get to what we call like a dew point at that point, where then when the temperature starts to cool and it becomes saturated, then the water condensates, right? And it ends up coming out of the air, okay? So we have like two different points. Let me show you, okay? So the dew point is the temperature at which the cooled air becomes saturated. So that means this little beacon of water, okay, this little air fills all the way up and it can't hold any more, right, in the low temperature, okay? Remember, if this one fills up more here, it actually has more water vapor, right? But once it gets to the top and it's so full and so saturated, 100%, it can't hold anymore, what happens? Condensation. That's when we get dew fog or rain because we're at 100% humidity, meaning our dew point, and that means that we get condensation, and we get condensation in dew in the morning, which is the little tiny droplets on the ground, and those tiny droplets are because the water is condensating in the air because it's cooling down, so now that moisture can't go anywhere, okay? So it turns into those little droplets all over the ground outside, like on the petals and the grass and everything in the morning, and that would be the dew, okay, on the morning. Then sometimes when it's foggy in the morning, that's again because the water is now, the temperature is getting colder, right? And or warmer to colder, and that water vapor is changing. So then it's ending up giving us fog. Then sometimes that water vapor ends up turning into rain, right? Which is the process of it turning all back into liquid, okay? Just like our water cycle, right? We know our water cycle, right? Evaporation goes up, condensation happens, and precipitation comes back down. So we're in that cycle right now going through that, and that is condensation. So another example is if you were to take your glass, do it today. You'll see it. Okay, go inside today, get a glass of water, throw some ice in it, right? And now go take it outside and set it outside because it's going to be nice and hot today. What's going to happen? You're going to start to see that the temperature inside the glass and the temperature outside the glass are different, right? And the water vapor in both going from hotter to colder and colder to hotter because the temperatures are different, that water vapor turns into condensation, and those little droplets form on the outside of the glass, right? And that is because of the process of the changing, and that the water vapor has nowhere else to go, and it churns into those little tiny droplets on your glass. That's why Mrs.Lawler does not want you guys having your water bottles that have those little droplets, and that happens because the melting of the ice and the temperature in our classroom, right, ends up getting those little droplets, and then it gets water all over your table, and then you end up getting your paper all wet. That's why Mrs.Lawler always wants your water bottles where? In your cubbies, right? Obviously, it's a little bit different now because we're not in class, but don't do that on your countertop or where you're doing all your work because you're going to have the same thing, okay? So when the amount of water, and you can see here is like my little water like up here, when the amount of water or the humidity level gets to the part 100% humidity, it becomes saturated, we get all these little water droplets in it, and it falls down as our condensation, okay? Dew is that water vapor that condensates on the ground, okay? And then sometimes when that water vapor occurs and the dew starts on the ground, but the temperature outside is below freezing, we then get frost. And that's where you get that little frost layer across the grass, because we don't get a lot of frost here, but sometimes in the morning we get that little bit of frost layer. And I think we got a little bit of that over in November and December this year. But that's when the water vapor freezes on the ground because the temperature is below freezing. Okay, so this was relative humidity, saturated, dew point, condensation, dew, and frost. And I hope that I did a better idea of showing you how to understand this. And I'm going to go ahead and press pause so you guys can get all of your notes down for this section 8.2.